beneath a starlit sky, where the hush of night settles over the earth and each shimmering point of light trembles with ancient fire. One cannot help but wonder what lies beyond. Every star is not merely a distant sun, but a portal into the unfathomable, the grand celestial unknown where reality bends and mystery reigns. This is the threshold where questions take root. What is our place in the universe? Why does it behave in ways that defy our best theories? What secrets lie curled within its deepest shadows? The cosmos, silent and unyielding, challenges us not with violence but with enigma. From the earliest human skywatchers charting stars with bare eyes to today's theorists manipulating the language of quantum fields, we have always sought to pull back the curtain of the night. But the more we discover, the more the void seems to whisper. What if the anomalies we observe, those strange alignments, fading stars, and silent signals are not merely noise in the data, but the universe itself, speaking in riddles we have yet to learn how to read? To stand beneath the stars is to stand beneath a mystery that grows deeper the more we illuminate it. The universe, once thought to be a tidy, expanding field of matter and energy governed by elegant laws, now reveals itself to be full of quiet rebellions against order. Consider the light that has traveled for billions of years to reach us, its journey long and tireless, weaving through dust, gravity wells, and magnetic fields only to arrive as a whisper on the lens of our telescopes. In that whisper lie secrets, background noise that isn't noise, variations that shouldn't exist, alignments too precise to be dismissed. The cosmic microwave background, for instance, was once considered the ultimate proof of a smooth, isotropic universe born from a hot Big Bang. But even it holds a dissonant note, a peculiar alignment known ominously as the axis of evil, where temperature fluctuations in the CMB appear to line up along the plane of Earth's orbit, violating the assumption that the universe should look roughly the same in all directions. Is this a cosmic coincidence? A statistical quirk? Or something far more profound, a fracture in the symmetry of space-time itself? This anomaly, undeterred by new instruments and refined data, endures. It raises questions not just about the early moments of the cosmos, but about whether our position within it is as ordinary as we once believed. It challenges the cosmological principle, the idea that no place in the universe is special, but what if it is? Other anomalies compound the puzzle. The Dipole Repeller, a vast region of space with an apparent gravitational push, defies intuition. It is not an object, not a cluster of mass, but rather a void, a sprawling absence that reshapes the trajectories of galaxies, guiding their flow not with attraction, but repulsion. While the great attractor draws matter toward it with an invisible hand, the Dipole Repeller seems to sculpt galactic motion in the opposite direction, as though the universe itself breathes in and out across inconceivably large scales. What could give emptiness such force? The mere existence of such a repulsive influence suggests that gravity, our most familiar of cosmic forces, may behave in ways we do not fully understand when confronted with true emptiness. Or perhaps it is not gravity alone at play, but dark energy or some other force not yet woven into our equations. These vast structures or anti-structures mock our instincts about cause and effect, pull and push, presence and absence. They dance just beyond comprehension, shaping the destiny of galaxies as if by phantom touch. And there are trails, like fingerprints left behind after celestial collisions, ghostly streams of stars, stretched across the sky in delicate, fading arcs. Speak of ancient galactic mergers, tides of destruction and rebirth played out on unimaginable timescales. These galactic ghost streams are not merely beautiful, they are memory given form. They drift silently through the cosmos, so faint that even our best instruments strain to detect them. They are what remain after a smaller galaxy is swallowed by a larger one, its stars torn and scattered, leaving behind glowing trails like the long sigh of something once whole. The Sagittarius stream in our own Milky Way is a haunting example, a whisper of a past collision still echoing through our spiral arms. These structures offer history lessons, not written in books, but in gravity and light. They remind us that the cosmos is not static, not serene, but kinetic and violent beneath its tranquil veneer. Yet these same trails also blur the edges of our understanding. Some do not conform to our models of gravitational dynamics. They twist and stretch in ways that suggest forces unaccounted for, or events beyond the bounds of prediction. They force us to look not just outward, but backward, trying to piece together a puzzle scattered across billions of years and billions of stars. Even the brightest lighthouses of the cosmos seem to conspire in mystery. Quasars, brilliant, ancient engines of energy surrounding supermassive black holes, are not merely distant beacons. They carry hidden messages in their light. Their radiation, when filtered through our instruments, shows signs of polarization, waves of light aligning in directions that, across billions of light years, should be random, yet they are not. Patterns have emerged, alignments stretching across vast swaths of sky, as if entire constellations of quasars had somehow synchronized their polarizations. What could cause such coherence across such distance? Some theorize that intergalactic magnetic fields have bent their light over time, imprinting an unseen structure onto the cosmos itself. Others suggest that these alignments are fossils' imprints of primordial conditions, frozen into the scaffolding of the universe at the moment of its birth. Or perhaps they hint at something even more radical, that space-time, on the largest scales, is woven with hidden symmetries, echoing patterns that transcend galaxies, epochs, and comprehension. Here again, we are left with signals we can observe, but not fully explain a Morse code tapped out by the stars that we have only just begun to translate. Even closer to home, the solar system harbors its own enigmas. Beyond Neptune lies the Kuiper Belt, a frozen hinterland of icy remnants from the solar system's formation. It should, by all accounts, stretch smoothly outward into the void, gradually thinning, yet at a distance of about 50 astronomical units. The distribution of objects drops off sharply a cliff in space known simply as the Kuiper Cliff. Why, what truncates the solar system so precisely? Could it be the gravitational influence of a hidden planet, an as yet unseen Planet 9 lurking in the cold, dark beyond? Or is it a relic of the solar system's chaotic infancy, shaped by migrations of the gas giants and scattering collisions that cleared the outskirts like broomstrokes in dust? Whatever the cause, this cutoff speaks of an invisible boundary, a line the universe itself seems to have drawn at the edge of our planetary domain. It is both a limit and a dare, calling us to cross it and find what lies on the other side. Far stranger still are the voices from the deep. Fast radio bursts, blindingly quick flashes of radio energy have confounded astronomers since their discovery. Some last only milliseconds, yet carry as much energy as the sun emits in days. Many come from distant galaxies, their origins veiled, their mechanisms unknown. Some repeat, some do not. A few have been traced to Magnetars, highly magnetized neutron stars whose fields are so strong they can twist atoms and erase data from spacecraft from thousands of miles away. These cosmic monsters, born in the death throes of giant stars, are engines of energy and chaos. Their quakes can ripple space-time. Their emissions reach across the stars. And yet their numbers are so few, only dozens known, that each new discovery reshapes our understanding of stellar death and high-energy physics. Could they be the source of these eerie bursts? Or do we still lack the key to understanding these signals, which seem to come from everywhere and nowhere, whispering a message we can hear but not yet decipher? And then there are the silences, the empty spaces that speak louder than noise, intergalactic voids, cosmic deserts where galaxies thin and then vanish, where gravity goes quiet and the light dims. Some of these voids are so vast that entire superclusters could drift through them without ever meeting another galaxy. Yet they are not nothing. They hold dark energy, magnetic fields, perhaps even unknown particles. Signals have been detected from within these voids, strange, persistent radio waves from regions where no galaxies dwell. Could these be echoes of ancient collisions, the death cries of long-vanished structures, or something entirely other? Phenomena born in isolation, beyond the reach of our frameworks. The universe does not offer us clean conclusions. It offers us riddles, wrapped in starlight, pulsing through the radio dark, folded into patterns of gravity and electromagnetic hush, for all our equations and models, for all our machines perched on mountains or circling Earth in the cold void. We remain in the infancy of cosmic comprehension. These anomalies, these strange behaviors and misbehaving lights, do not close the book of science. They open it. They remind us that the universe is not only grand, but layered with meanings we do not yet possess the language to describe. In every unexplained alignment, every vanished star, every echo from nowhere, we hear it again, the whisper in the darkness that says, "Keep going. There is more. There is always more." And in that whisper, fragile and fleeting, is the truest music of the cosmos. Not silence, not certainty, but wonder. Cosmic alignments and recoiling voids. Imagine drifting through the void, beyond the veil of stars, where silence reigns and the laws we once thought immutable begin to tremble. Out there, far from the warmth of the familiar, the universe whispers not in words, but in alignments, patterns, and movements subtle, defiant signatures that unsettle the very foundation of our cosmic understanding. This part of our journey ventures into a realm of disquieting mystery, where two anomalies rise not with thunder, but with an eerie, quiet defiance, the axis of evil and the Dipole Repeller. These are not characters of myth, but signatures etched into the cosmic canvas, challenges to the assumptions that have guided generations of cosmologists. They speak to us from the deepest stretches of space, not with clarity, but with riddles that make us question whether the universe we inhabit is as random and isotropic as we once believed, or if some vast and hidden architecture awaits discovery just beyond the limits of our perception. As we peer into the relic radiation of the Big Bang and trace the silent flows of galaxies, we begin to see something uncanny: alignments that should not exist, and empty places that push the cosmos itself. In this search for meaning, the line between science and wonder begins to blur, as we confront the unnerving possibility that there may be forces and forms at work that remain cloaked, not only in distance, but in a silence deeper than space. It begins with light, not the ordinary kind that flits through windows or reflects off water, but the most ancient glow, the afterimage of creation itself. The cosmic microwave background, or CMB, is our universe's baby picture, a relic radiation imprinted on the fabric of space some 3,000 years after the Big Bang. It is faint, cold, and nearly uniform, a soft hiss of microwaves whispering from all directions, a cosmic lullaby that lulled astronomers into thinking the universe was well-behaved on large scales. The cosmological principle, the idea that the universe, averaged over vast distances, looks the same in every direction was long held as a guiding assumption, a bedrock of cosmology. But then came the anomaly, an unsettling smudge in the data, a pattern that refused to fade. First detected by the Wilkinson Microwave Anisotropy Probe, WMAP, and later confirmed by the Planck satellite, a curious alignment appeared in the CMB's temperature fluctuations, stretching across the sky along a particular axis. This unlikely alignment, statistically improbable and persistently present, soon earned a provocative name: the axis of evil. Its moniker, coined half in jest, captured the discomfort it stirred among scientists. Here was something that shouldn't be: a crack in the elegant symmetry of the cosmos. The axis aligned suspiciously with the plane of Earth's orbit, an alignment that raised the possibility of measurement bias or local contamination. Yet attempts to scrub it away through modeling and corrections only seemed to confirm its tenacity. Like a shadow that won't dissolve in the light, the axis lingered, suggesting a directional preference in the oldest light. We have an affront to isotropy, and perhaps to simplicity itself. The axis of evil confronts us with more than just a glitch. It threatens the philosophical underpinnings of cosmology. If the universe has a preferred direction, if the oldest photons we can see are etched with asymmetry, then the very idea of a uniform cosmos falters. Theories abound to explain it. Some posit that the anomaly is an observational artifact, a statistical fluke born from our single vantage point within a vast multiverse. Others propose that we're glimpsing the aftershock of something immense, perhaps a collision with another universe, one that grazed our own like a ghost ship scraping the hull of reality. More speculative still are hypotheses involving primordial magnetic fields or unknown forms of anisotropic dark energy that might have imposed structure on the infant universe. In each case, the axis of evil invites not comfort, but vertigo, a sense that we are standing on the edge of an unfinished story, whose ending we are not yet meant to read. And yet, for all its menace, it also ignites the flame of curiosity. What if this anomaly is not a problem, but a clue? What if it is not an error to be corrected, but a signal, however faint, that we are glimpsing the deep scaffolding of the cosmos, a design far stranger and more deliberate than we have ever dared imagine? As our gaze shifts from the relic light of the early universe to the present dance of galaxies, we encounter a second anomaly, equally silent and equally defiant. The Dipole Repeller is not a glowing beacon or a gravitational anchor. It is an absence, a void with invisible hands, unlike the axis of evil, which unsettles the heavens with its alignment. The Dipole Repeller exerts its mystery through motion, galactic motion. In the cosmic sea, galaxies are not stationary islands. They flow, pulled and pushed by the uneven distribution of mass. For decades, astronomers noticed that our local group of galaxies was moving at an unusually high velocity relative to the CMB, pulled in part by a massive concentration of galaxies known as the Great Attractor. But this pull was not the whole story. The trajectory of motion required something more, an unseen push. In 2017, astronomers analyzing the Cosmic Flows 3 survey discovered that our motion was not only due to gravitational attraction, but also to repulsion. They identified a vast, underdense region of space, a void with enough gravitational contrast to repel galaxies. This ghostly absence became known as the Dipole Repeller. Unlike the Great Attractor, the Dipole Repeller cannot be seen in traditional images of the sky. It is a structure of inference, known not by what it emits, but by how it shapes the flows around it. Galaxies flee from its coordinates, their motions echoing the contours of gravitational imbalance. It is, in essence, a negative space whose influence rivals that of the densest clusters. And therein lies the paradox. How can emptiness exert a force? The answer lies in the subtleties of gravity on cosmological scales. Dense regions pull, but voids, being less dense than their surroundings, create gradients that effectively push. It is not a repulsion in the electromagnetic sense, but a gravitational choreography, a recoiling dance that emerges from contrast. The Dipole Repeller is a sculptor of galactic paths, a silent architect shaping the universe not through presence, but through absence, and like the axis of evil, it raises profound questions about the structure and origin of cosmic flows. Are these alignments and motions mere accidents, or are they echoes of deeper laws, hidden dimensions, or a history we have yet to uncover? Together, the axis of evil and the Dipole Repeller frame a haunting question. What if the universe is not isotropic, not homogeneous, but instead patterned by unseen forces and fossil scars of primordial events? What if voids and alignments are not quirks but keys? Keys that unlock doors to a pre-inflationary universe, to entanglements between our cosmos and others, to a topography of space shaped not only by mass and energy, but by conditions we cannot yet measure. In these questions lies the emotional weight of cosmology, the tension between what we observe and what we believe. These anomalies do not merely tweak equations, and they invite a reimagining of the universe as a place not of serene uniformity, but of dynamic asymmetry, of hidden engines that propel galaxies and stretch the very fabric of space. It is humbling to consider that our most powerful tools, satellites, surveys, simulations, still illuminate only fragments of the grand design. Each new map of the sky is like a lantern in a cathedral, revealing frescoes too vast to grasp, too dim to decipher in full. And yet we are driven onward, not because we expect closure, but because each anomaly is a promise that the universe still has stories to tell. The axis of evil and the Dipole Repeller are whispers from the edge of comprehension, subtle deflections in the script of space and time. They are reminders that reality is not always polite, not always symmetric, not always predictable, but it is beautiful, melancholically beautiful, because to witness the universe in its mystery is to be part of something that endlessly outpaces us, that invites us to reach, even when we cannot grasp. The great irony is that these vast structures, the axis stretching across the sky, the repeller lurking in the abyss, are discovered not with our eyes, but with patience, mathematics, and an unyielding faith that patterns, however faint, can be found. And so we search, measuring polarization angles, mapping redshifts, constructing gravitational velocity fields like cartographers of an unseen continent. In this work, cosmology becomes more than science. It becomes a kind of pilgrimage, a journey toward the hidden harmonies of the universe. Perhaps one day, with more precise instruments and deeper theories, we will see not just the shadows, but the causes behind them. Perhaps we will trace the axis to a bubble wall in a multiverse sea, or understand the repeller as a relic of topological variations seated in a pre-quantum epoch. Or perhaps we will find only deeper puzzles, each answer birthing a new mystery in an infinite regress that mimics the very expansion of space. But even then, we will not have failed, for the goal is not to end the mystery, but to expand the horizon of the known. These anomalies, these trembling irregularities in the fabric of the cosmos, are not cracks in science, they are its frontier. They call us forward, into the deep, into the cold, into the silence where stars align and voids breathe. And in that silence, we listen for the shape of what is still to come. Echoes of galactic memory, streams and light patterns. Imagine drifting in the silence between galaxies, where time slows and ancient light whispers across the dark. In this inky canvas, there exist traces so faint they nearly escape the eye. Tenuous, gossamer trails stretched across millions of light years like the fading footprints of celestial giants. These are the galactic ghost streams, ethereal remnants of ancient galactic collisions, the long-forgotten relics of cosmic cannibalism and gravitational entanglement. They do not blaze across the cosmos like quasars or erupt in cataclysm like supernovae. Instead, they linger, delicate and spectral, formed when galaxies brush too close, ensnared by each other's gravity in a silent, slow-motion dance that ends with one devouring the other, as stars are stripped from their hosts and slung into the void. They form ribbons of stellar debris, haunting monuments to mergers that took place eons ago. These streams are like faint murmurs of memory, barely perceptible against the glow of the galactic night. And yet they hold stories of breathtaking violence and transformation to the naked eye. They are invisible to astronomers with deep sky surveys and wide-field infrared telescopes. They are fragile stitches in the cosmic fabric, hinting at episodes of upheaval that reshape the architecture of entire galaxies. Among them, the Sagittarius stream in our own Milky Way stands out, a sprawling loop of stars torn from a dwarf galaxy as it was gradually consumed by our galactic core. Like a ghost circling its grave, it arcs across the night, testifying to a time when our galaxy was not a quiet spiral, but a predator in a stellar jungle. Detecting such streams demands more than technology. It requires patience, serendipity, and a relentless willingness to chase shadows. The stars within these streams do not burn brighter than their neighbors. They do not cry out. Their arrangement is their only clue: elongated, curved, whispering of orbits stretched by tidal forces, of gravitational embraces that reached across space and time. Long exposures, motion tracking, and digital sky surveys piece together these faint threads, revealing more of them with each passing year. And what they tell us is astonishing. The universe is not a static mosaic, but a dynamic, ever-evolving structure. Galaxies grow not just by birthing new stars, but by consuming one another, merging and assimilating in processes that take billions of years yet leave behind unmistakable scars. These ghost streams are fossils, and astronomers have become their paleontologists, reconstructing the family trees of galaxies from their long-lost limbs. Sometimes, the cannibal is not even the predator. Dwarf galaxies swept into larger hosts may themselves have devoured smaller companions in their own pasts. Each stream becomes a layered story, a branching history of creation and consumption. But not all cosmic memories are drawn in stars. Some are encoded in light itself, etched into the oscillations of electromagnetic waves traveling across unimaginable distances. Enter the quasar, among the most powerful and luminous objects in the universe. At the center of distant galaxies, supermassive black holes feast on infalling matter, releasing torrents of energy as they spin and blaze with the light of unmaking. These quasars are beacons from the early universe, some shining across the abyss for more than 10 billion years. Yet their brilliance is not their only wonder. As their light journeys toward us, it becomes subtly polarized, its waves aligned in particular directions. Normally, light vibrates in every plane perpendicular to its path, chaotic and free. But when it interacts with magnetic fields, gas clouds, or dust, it becomes ordered, filtered. What's astonishing is that quasar light across billions of light years appears not only polarized, but aligned in ways that defy explanation. These polarization vectors, separated by cosmic gulfs that should render them independent, seem to point in similar directions, as if the universe itself is organizing the orientation of light. This phenomenon, so statistically improbable it borders on the uncanny, suggests that something deeper is at work, something embedded not in the quasars themselves, but in the intergalactic medium, in the very geometry of space-time, or perhaps in a primordial memory etched into the universe's infancy. What could cause such coherence on such enormous scales? Magnetic fields stretching across intergalactic space might subtly twist the light as it passes through, like ancient weavers guiding cosmic threads through invisible looms. These fields, though weak, can impose directionality over eons and distances, shaping the quasar's light into subtle patterns. Alternatively, the light may be passing through cosmic filaments, massive tendrils of dark matter and gas that form the scaffolding of the cosmic web. These structures could act as vast, anisotropic lenses, rotating and aligning light as it threads through them. Or perhaps we are seeing something even more profound, a fossil of the universe's initial conditions, a leftover ripple from inflation, frozen into the polarization of photons born in an earlier epoch. That these alignments might reflect some deep asymmetry in the fabric of the cosmos calls into question our assumptions about its isotropy, that it is the same in all directions. If this uniformity breaks, even in the subtlest ways, then our models must be revised, and the map of the universe redrawn. Quasar polarization may sound like a technical footnote, but it strikes at the heart of cosmology. These beacons, scattered across the cosmos, become a new kind of telescope, a way to look not at things, but through them, into the forces and fields that structure the universe. And yet, like the ghost streams, they are elusive, their light is faint, their signals buried in the noise of the cosmos. Detecting and measuring polarization with accuracy requires specialized instruments. Polarimeters capable of measuring the angle and degree of alignment with extraordinary precision. Observations must account for intervening dust, galactic emissions, and the vagaries of atmosphere and telescope. And yet, when these barriers are overcome, the patterns persist. Alignments emerge not in isolated regions, but across hemispheres, across epochs. The message, if there is one, is subtle but persistent. Something is shaping the light from the edges of the observable universe, something coherent, something large, something unknown. Together, ghost streams and quasar polarization form a kind of cosmic symphony. Two very different melodies, each echoing across time and space, each whispering of hidden histories. One tells of gravitational violence and mergers past. The other hints at a lattice of invisible forces that shape light itself. They are not random curiosities, but pieces of a puzzle, suggestions that the universe contains an architecture we have barely begun to grasp. Perhaps there are relic symmetries from a time before stars, before galaxies, signatures from a deeper layer of physics that ripple upward into the structures we now observe. Perhaps these patterns reflect a universe that is not just expanding, but evolving toward complexity, toward coherence, toward something intelligible. Or perhaps they are signs of our own limitations, our anthropic perspective peeking through the veil, imposing order where there is only chaos. And yet, the data remains. The stars are there, the light is aligned, and the streams persist, drifting slowly like the last breath of something long gone. In this interplay of gravity and light, in the faint scars and luminous alignments, we glimpse a kind of galactic memory, a memory not made of neurons or thoughts, but of trajectories, distortions, and waveforms of the gravitational scripts galaxies follow, and the radiant signatures left in their wake. These memories are not conscious, but they are legible. They are inscribed across billions of light years, carried by stars and photons alike, waiting for minds patient enough to decode them. The cosmos, it seems, remembers not in stories, but in structure, not in words, but in wavelengths, and in that remembrance, we find both wonder and humility, for we, too, are part of this great memory. We are stardust reorganized into sentience, fleetingly aware of the ancient forces that shaped us. We look up, and in the light from distant quasars, in the wisps of ghostly star streams, we recognize something familiar, an echo of becoming, a fragment of a larger tale. And perhaps that is the greatest mystery of all, that the universe, vast and ancient and indifferent, speaks in patterns, and that we, ephemeral as we are, can still learn to listen. Perimeters of the known, the Kuiper Cliff, and the Magnetar enigma. At the edge of everything we know, where the warmth of the sun fades into a pale glimmer and solar winds no longer blow with strength, there exists a silence that speaks of unresolved riddles beyond Neptune's orbit, where the Kuiper belt sprawls like a frozen debris field circling the sun. Astronomers once expected a steady population of icy remnants fossils from the solar system's formation to stretch far into the darkness. Yet, just past 50 astronomical units, something inexplicable occurs. The Kuiper belt abruptly ends, this stark drop in the number of objects, now hauntingly known as the Kuiper Cliff, is not a gentle fading away but a sudden plunge. As if the cosmos changed its mind, no clear gradient, no slow diminishment, only a conspicuous emptiness where once there was anticipated abundance. It is a cosmic cliff edge where possibility falls into silence. What could have swept this region clean, or never allowed it to form at all? Some suggest the gravity of a distant, undiscovered planet, Planet 9, lurking far beyond our telescopic reach, pulling on icy bodies and warping their orbits into hidden pathways. Others propose that early migrations of Jupiter and Saturn, or ancient interactions with rogue stars, sent gravitational shock waves through the solar nursery, scattering debris like leaves in a storm. Still others argue that this edge is simply where the primordial protoplanetary disk faded into nothing, a natural outer boundary of the sun's original birth cloud. But none of these theories fully satisfy the abruptness, the precision, the mystery of the cliff. It remains an open question in planetary science, a glaring omission in an otherwise elegant model. This outer boundary is not just spatial, it is epistemological. The Kuiper Cliff defines not only a limit to where most trans-Neptunian objects dwell, but also to how far our current understanding can stretch before it falters. Spacecraft like Voyager and New Horizons have slipped into this realm, sending back ghostly portraits of icy dwarfs and lonely rocks, hinting at a frontier that remains largely unexplored. Here, our maps become probabilistic, our models wobble. The expected fades into the enigmatic. We are reminded that the solar system, for all our charts and probes, still keeps secrets in its outermost shadows. It is at these margins that our theories reveal their gaps, and we encounter the humbling truth that we are still, in so many ways, beginners. The Kuiper Cliff is not a final line, but an invitation, a question mark drawn in the cold, urging us to peer deeper, to search with sharper instruments, and to rethink the assumptions we have taken for granted. It is a gentle mystery, quiet in its challenge, yet profound in implication. If our solar system has such abrupt structural features we have yet to explain, what of other star systems? What of the galactic edge? What unseen forces shape the perimeters of the known? But as we contemplate the icy silence of the outer solar system, a radically different anomaly roars from across the void, an explosion of force and mystery found not in the cold, but in the crucible of stellar death, deep in the galactic graveyards. Among the remnants of supernovae dwell the Magnetars neutron stars with magnetic fields so intense they make even the strongest laboratory magnets seem like toys. These compact cores, only a dozen kilometers wide yet holding more mass than our Sun, are the densest forms of matter known outside black holes. But some neutron stars go even further. A rare few evolve into magnetars. Their magnetic fields 1,000 times stronger than typical neutron stars, reaching intensities that defy comprehension enough to warp atoms, crack open the crust of the star itself, and potentially rip the very fabric of space-time. These celestial monsters do not whisper their presence. They shriek, with sudden gamma-ray flares and bursts of high-energy X-rays. They unleash tantrums so powerful they can be detected across galaxies. In 2004, a magnetar in our Milky Way SGR 180620 emitted a flare so intense it briefly altered Earth's ionosphere. Despite being 50 light-years away, had it been closer, it might have fried our satellites or even our atmosphere. These eruptions are believed to stem from starquakes, sudden rearrangements in the crust of the neutron star. Driven by the immense stress of magnetic pressure, it is as if the magnetar itself struggles under the weight of its own internal chaos. But magnetars are not merely loud, they are elusive. Their lives are short, their births rare, and what they might be telling us could extend far beyond neutron star physics. In recent years, a tantalizing connection has emerged between magnetars and fast radio bursts, FRBs, brief, millisecond flashes of radio energy from distant galaxies that once defied all classification. The mysterious nature of FRBs, some repeating, others not, had fueled wild speculation alien technology, decaying cosmic strings, echoes of black hole mergers. Then, in 2020, an FRB was traced to a known galactic magnetar, suggesting a concrete astrophysical source for at least some of these phenomena. Yet even this apparent clarity deepens the enigma. How can such short, sharp signals arise from something so massive, so dense, so slow by comparison? What does it mean that magnetars can produce both high-energy gamma flares and low-energy radio flashes? Are we witnessing different facets of a single physical process? Or is the magnetar merely a conduit for more exotic mechanisms, perhaps involving quantum electrodynamics, axion-like particles, or interactions with the dark sector? Indeed, magnetars push the boundaries of our physical theories into regimes we cannot replicate on Earth. The magnetic field strength near a magnetar exceeds the quantum critical limit, where even the vacuum becomes nonlinear, altering the behavior of light and matter in ways predicted only by quantum electrodynamics. At these field intensities, atoms deform into pencil-thin structures, and photons can split or merge in defiance of classical expectations. Some theorists posit that magnetars might be natural laboratories for new physics, offering glimpses into the behavior of matter at the intersection of general relativity, quantum mechanics, and extreme conditions. Others speculate that these stars might help probe the elusive nature of dark matter, acting as gravitational traps for exotic particles whose annihilations might subtly alter magnetar dynamics. We are far from understanding them fully. Like the Kuiper Cliff, magnetars represent a kind of frontier, a place where our models hesitate, where equations strain, where intuition fails. They are not the edge of space, but the edge of physical law. The contrast between the Kuiper Cliff and the magnetar enigma is striking. One is quiet, remote, spatially mysterious. The other violent, compact, temporally sudden, and yet they share something fundamental. Both sit at the boundary of our comprehension. One is a puzzle of absence, the other of excess. One challenges our understanding of gravitational dynamics in the outskirts of our solar neighborhood. The other tests our knowledge of matter and magnetism at nuclear densities. One pulls us outward, the other inward, and both whisper, in their own dialects, of a universe richer, stranger, and more dynamic than we dared imagine. They remind us that reality does not conform neatly to human expectation. They force us to question our frameworks, not to discard them, but to evolve them, to stretch them toward truths we have not yet glimpsed. These phenomena, though distant, reflect something deeply human. We, too, stand at a kind of boundary between knowledge and mystery, between comfort and curiosity, just as the Kuiper Cliff marks the outer limit of what we thought we understood about the solar system, and just as magnetars push the internal coherence of matter to breaking. So we live in a state of perpetual inquiry, straining toward insight with instruments and equations, but also with wonder and metaphor. The universe does not give up its secrets easily, and yet, through cliffs and flares, through silence and fury, it speaks to us still. In that speaking, we are reminded that science is not merely the accumulation of facts, but the cultivation of awe, that physics, at its most honest, is an act of listening, and that even in the perimeters of the known, there are echoes of something vast and unnamed, waiting to be felt. Hidden cores and missing elements. In the frigid twilight of the solar system, far beyond the rocky inner planets and the familiar gas giants, drifts a world that whispers secrets it refuses to yield. Uranus, a cyan orb suspended in the void, is often overlooked, quiet, cold, seemingly uneventful, yet beneath its serene surface lies one of the most profound enigmas of planetary science. Unlike Jupiter or Saturn, with their storms and swirling belts, or even Neptune, its deep blue twin, Uranus is eerily muted. It radiates almost no internal heat. Its thermal signature is so faint that the planet appears to emit less energy than it receives from the Sun, a stark contrast to its planetary siblings. This thermal silence suggests an interior unlike anything we've modeled, a core that may hold secrets not just about Uranus itself, but about the broader processes that shape the architecture of the solar system. And then, there is the tilt Uranus spins nearly sideways, its rotational axis lying almost in the plane of its orbit, like a planet tipped and forgotten. The cause may have been cataclysmic, a titanic collision in the solar system's youth, or the slow gravitational sabotage of unseen forces, sculpting its orientation over eons. This orientation has consequences: extreme seasonal cycles, a magnetic field misaligned from its core, and an interior structure that may be layered, chaotic, or fundamentally different from what we expect. We cannot peer directly inside, but we suspect that the core may be home to materials we barely understand, such as superionic ice, a state where water behaves as both solid and liquid, its ions moving like ghostly currents through a crystalline lattice. This strange form of matter, predicted in high-pressure simulations, may not only exist in Uranus but dominate its internal structure. If so, it challenges how we model conductivity, heat flow, and the very definitions of phase transitions under planetary conditions. And in this planetary riddle, this elegant silence of Uranus, we find a metaphor for a deeper mystery, one etched not in planetary behavior, but in elemental fingerprints cast across the entire cosmos, for scattered throughout the stars, in the hearts of galaxies and the halos of ancient stellar remnants, lies a mismatch that has troubled cosmologists for decades: the lithium problem. When the universe was but minutes old, it forged the first elements in a process known as Big Bang nucleosynthesis hydrogen. helium, and traces of lithium. The ratios of these elements were predicted with extraordinary precision, a rare success in cosmology's attempt to align theory with observation. And yet, as we look to the oldest stars, those ancient population tube beacons whose light carries the memory of primordial creation, we find far less lithium than we should. In some stars, the lithium abundance is a third of the expected value. In others, it's nearly absent. This is no small discrepancy. It's a fracture at the base of a model we otherwise trust. A problem that refuses to be soothed by statistical error or observational imprecision. The elements are the universe's memory. When one of them goes missing, it's as if part of our cosmic history has been redacted. So where is it? Some theories suggest that lithium is not truly missing, but hidden, burned away in the interiors of stars through mechanisms more subtle than we've accounted for. Perhaps convective mixing or atomic diffusion pulls lithium deep into stellar hearts, where it is destroyed in nuclear reactions and never reemerges. But this hypothesis struggles with uniformity. Why do so many stars, across such varied types and epochs, show the same unexpected shortfall? Could there be flaws in our nuclear physics, in the reaction rates assumed during Big Bang nucleosynthesis? Or are more exotic culprits at play? Some physicists have pointed fingers at hypothetical particles, axions, sterile neutrinos, or other dark sector interactions that might have altered the cooling rate of the early universe or shifted the balance of elemental synthesis. Others have speculated on asymmetric baryogenesis, time-varying constants, or alternative cosmologies that tweak the fundamental timeline of the early universe, just enough to explain the discrepancy. These are not fringe ideas, but serious conjectures emerging from the space between theory and observation. From the tension that arises when a model elegant in its mathematics confronts a sky that refuses to conform. The lithium problem and Uranus's interior, seemingly unrelated, are bound by a deeper truth. They are reminders that science, for all its rigor, remains a human endeavor, fallible, fragile, always incomplete. Each model we build is a map, not the territory, a sketch drawn with the best instruments we possess, guided by the logic of mathematics and the humility of measurement. But some landscapes resist our gaze. Some truths remain just out of reach, like the icy pressure chambers deep inside Uranus, or the primordial reactions that lit the first fires of elemental birth. In both cases, we are left navigating by inference, reaching for understanding in the darkness between data points. And yet, it is in that reaching in, that stretching of theory toward anomaly, that science becomes most profound. It is not in certainty, but in doubt that discovery lives. To contemplate these mysteries is to confront a universe not built for our comprehension, but rich enough to reward our persistence. Uranus drifts in its orbital solitude, bearing scars of trauma and containing an interior that may hold new states of matter. Lithium whispers of a misremembered beginning, its absence questioning our confidence in the earliest pages of the cosmic story. Together, they speak of a cosmos where every silence is significant, every inconsistency a clue. We do not know if we will solve these puzzles in this century, or ever. Perhaps new missions to Uranus will finally dive into its atmosphere and pierce the veil of its interior. Perhaps future telescopes will refine our stellar models, or uncover new particles that restore lithium to its rightful place. Or perhaps, as often happens in science, the answer will come from an unexpected angle, a theoretical leap that reframes the question itself. Until then, we carry these anomalies like riddles folded into the star maps of our understanding. We look outward with eyes that seek symmetry, but find beauty even in asymmetry. We listen for the rhythm of reason, but are not afraid of dissonance, because somewhere in that dissonance lies the voice of the cosmos, still speaking, still singing, still waiting to be heard. Radio ghosts and dust veils, signals from the unknown, in the boundless dark between galaxies, where the thin fabric of space stretches in silence and the density of matter thins to near nothingness. There come flickers, faint, defiant flickers, not of light, not of structure, but of radio waves, ghostly whispers traveling unimaginable distances, haunting the cosmos with their slow, drifting rhythm. These are not the familiar crackles of pulsars or the burst patterns of known stars. They are slower, broader, stranger. They rise not from within the spiraling arms of galaxies, but from the peripheries of cosmic maps, from voids that should be silent. For decades, astronomers have cataloged strange radio emissions that seem to come from nowhere, flickering into the sensitive ears of radio telescopes with no matching optical source. Some drift in frequency, others persist without explanation, and a few arrive with such regularity that speculation drifts from the scientific to the speculative, from the realm of plasma and black holes to the eerie corridors of hypothetical technology and unknown cosmic actors. And yet, to leap to aliens is to skip the poetry of the question. What if these signals are the language of galaxies, speaking in tones we have only begun to understand? What if this radio static is the soundtrack of the void, a resonance of collisions, of magnetized plasma arcs, of dark matter interactions far beyond our current physics? Among the leading contenders for these ghost signals are active galactic nuclei, supermassive black holes at the centers of galaxies, cloaked in magnetic fury, that can send out collimated jets of energy stretching across millions of light years. These radio lobes, interacting with the intergalactic medium, can distort and scatter, creating echoes that outlive their source. Or perhaps the sources are dying stars in intergalactic exile, ejected from their galaxies by gravitational chaos, now pulsing their last messages across a vacuum no one was meant to hear. Some signals may even originate in galaxy cluster interactions when massive galactic bodies merge. The resulting plasma shocks can emit radio waves on scales that defy intuition. And yet, the true mystery lies in the ones that do not fit any known category. They do not repeat like pulsars. They do not flash like fast radio bursts. They drift, they linger, and then they vanish. They do not ask to be found. They simply exist, waiting to be noticed. And what of the veils? If radio signals are the voices of the void, then interstellar and intergalactic dust clouds are its silences. These clouds, composed of microscopic grains of carbon, silicates, and frozen gases, stretch across the Milky Way and beyond, scattering and absorbing light in ways that both reveal and deceive. They are born in the atmospheres of dying stars and the shock waves of supernovae, but they do not die quickly. Instead, they drift carried by the tides of galactic winds and magnetic fields, accumulating in dark filaments that stretch across the sky. To the naked eye, they are nothing, but to astronomers, they are distortions biasing the light from distant galaxies, muting the brightness of supernovae, reddening the colors of starlight. In the pursuit of precision cosmology, dust is the eternal contaminant, but it is also a storyteller. For inside those grains are chemical records of ancient furnaces, isotopic signatures of stellar deaths, and the raw material of future planetary systems. Dust is not just a nuisance, it is memory. It is the medium through which stars form and through which the light of the universe must pass. There are clouds vast and faint that defy classification, cold, dark molecular clouds in the outer reaches of our galaxy harbor the seeds of future stars, yet others, high above the galactic plane, are so faint that they can only be seen when backlit by quasars or mapped by the dimmest of infrared echoes. These are the whispering veils of the universe, half visible, half imagined. Are they leftovers refused from galactic collisions, cast into the void like the spray of an ocean wave? Or are they the embryos of something new, nurseries not yet ignited, clumps of potential awaiting the right trigger? The answer remains as unclear as the clouds themselves. In every observation lies a distortion, in every correction, a new uncertainty, and still, we measure, we map, we model, we chase clarity through veils that shimmer and shift. It is humbling to know that some of the universe's greatest mysteries may not lie in what is distant or rare, but in what is faint, not in the spectacular bursts of gamma rays or the luminous death of stars, but in the slow pulse of radiostatic and the quiet glow of dust. These are the universe's margins, the things too dim to dominate, too subtle to ignore. They teach us that not all knowledge is bright, not all truths are loud. That in the quiet, in the veil, in the flicker, there is revelation, and in the search for meaning among the softest signals and the faintest shadows, we are reminded of the fragility of our vision, the limits of our models, and the beauty of a cosmos that will always remain partly unknown. So let us end not with certainty, but with reverence for the ghosts that drift between the galaxies, and the veils that drape the stars, for the silence that speaks, and the darkness that reveals. Let us carry these mysteries not as failures, but as invitations, to listen closer, to look deeper, to wonder longer, because beyond the reach of even our most sensitive instruments, the universe is still speaking in a language made of light and dust, signal and silence, knowledge and awe. And so we arrive at the end, or perhaps only the edge of the beginning, after venturing across ancient trails of stars and diving deep into galactic voids. After listening to the echoes of quasars and unraveling the magnetic tantrums of dying stars, we are left with something stranger than certainty's wonder. Not the kind of wonder born from answers, but from the realization that even the most precise instruments, the most elegant equations, and the most powerful telescopes are merely fingertips brushing the surface of a vast, unseen architecture. What have we found? Ghost streams whispering of ancient collisions, light bending to forgotten alignments, cosmic voids that repel galaxies like silent oars rowing through nothing, planets that refuse to radiate, elements that hide from our grasp, signals flickering from between galaxies, unclaimed by any known source, and dust everywhere, dust that dims and veils and guards the secrets of the stars. These are not just curiosities, they are messages. They are the universe leaning down and murmuring, "You do not yet understand me." But we try. With each anomaly, we expand the perimeter of the known. With each inconsistency, we are offered a portal into deeper laws. Science was never meant to be a fixed edifice. It is a raft in a storm, a melody played against silence. We do not map the cosmos to find comfort. We map it to remember that discomfort is a sign we are close to truth, that when a star vanishes without reason, or a polarization stretches across billions of light years, it is not failure, it is invitation. And behind all of it is time, time not just as ticking clocks or spinning orbits, but as a vast unfolding. These anomalies are fossils of motion, footprints in gravity, bruises left by forgotten giants. We are not outside this story. We are made of it. The lithium that should have been but isn't, the magnetar that screams once and dies, the rogue planet that drifts unloved through darkness. They are part of the same ledger that recorded your birth, your breath, your gaze upward on a cold night.